It is now almost 1 year since the COVID-19 crisis began. We have hundreds of COVID-19 tests available, but one question keeps coming up. Are these tests any good? Now, many of my viewers have reached out to me telling me about their experience with false negatives and false positive results. But there isn't much information available to evaluate this question holistically. This question continues to remain very relevant about the accuracy and reliability of these tests. Hello everyone, I'm Naveen Agarwal, and I want to welcome all of you once again to my weekly video update. Now recently, the FDA issued a safety communication regarding one specific test. So it caught my eye because why would this single out one specific test and not talk about this issue across the board? Is it a one-off issue with this specific test? Or the problem with other tests is not that bad? I wanted to find that out. So in this video, I will talk about this specific test and share with you some of my ideas why they might have flagged this. But keep in mind, that's pure speculation on my part. I don't know. But I will share with you my ideas and invite discussion on that topic. But I will also review with you my analysis of the MDR data, which is medical device reporting data, over a period of 1 year on these tests. So we'll look into both of these topics and figure out what might be happening here. So let's look into this. So this is the FDA Safety Communication that was issued on January 4 of this year. And this pertains to the risk of false results with the curative SARS-CoV-2 test for COVID-19. This is the specific test we are talking about. And in particular, FDA is worried about the risk of false negatives. And we can understand why. If it's a false negative, the person actually is infected with the SARS-CoV-2 virus, but the test is telling us they are not. So that's a big risk because the treatment can be delayed, their condition may worsen, they may infect other people. So those are the kind of concerns that come to mind, which are a risk because of these false negatives. So let's look into this test. This test is freely available at more than 10,000 locations across the United States. And just the other day, I saw this van parked next to my office here in Jacksonville, Florida, and a big sign saying free testing. And I was curious to learn what this specific test is. You might have seen a similar van or a kiosk in your area. So looks like it is broadly available. It is free. So presumably many tests are being done. Millions of tests are being done across the country. And maybe that is why FDA might be concerned. Now the second element is that the samples are self-collected under the supervision of a trained healthcare worker. Maybe that's an issue. I do not know for sure, as I mentioned, but there is a reason why FDA is flagging this in their safety communication. Let's look into some details of this EUA, which is Emergency Use Authorization. It was first granted on April 16th, but revised on June 11th. Minor revision, so not a big change. It's an RT-PCR test, so it is not a rapid antigen test. It is a molecular diagnostic test, which is expected to be quite accurate. Samples can come from oropharyngeal swabs, which is at the back of your throat, nasopharyngeal swab, which is deep in the nasal cavity, or mid-turbinate nasal swabs or oral fluids. So pretty broad range of samples. Target is the viral RNA, not the antigen, as I mentioned. There are some limitations that the nasal and oral swabs are limited to only symptomatic individuals who have shown symptoms within the last 14 days. And they are self-collected in the presence of a healthcare worker. Now, those are the two big issues about self-collection, even though it's under the supervision of a healthcare worker. But the samples are tested in a CLIA high complexity lab. It is not tested on site. So that might be another issue. There is a transportation issue, there is a storage issue, handling issue. Again, we don't know what are the contributing factors, but apparently FDA considers this to be a pretty significant risk for public health for them to issue this safety communication. So as I mentioned, is this a one-off issue or is it going on with other tests as well? So I looked into this FDA's TPLC database, which is Total Product Life cycle database. Very good database. You can check it out. You can get data for any product code. In this case, the relevant product code is QJR, which stands for Nucleic Acid-Based Molecular Diagnostic Test, particularly for COVID-19. And I looked at data from January 2020 to January of 2021. So more than a year worth of data. And here's what I found. Here's a summary. As you can see, more than 1,500 MDRs of incorrect, inadequate, imprecise results, output problems, false positive results, non-reproducible results, false negative results. Hundreds of these MDRs are being reported across the board. And if I dig deeper, many manufacturers of these IVDs, many big well-known names are included. And I do not want to show data by manufacturer here. If you're interested, you can look up the data yourself. The reason I don't want to do that is because it'll be an unfair comparison. Sometimes the number might look big for them because they're also doing many more times tests than other test manufacturers. So we cannot compare that data side by side, and I don't want to give misleading information to you. But this is data as an aggregate of all the reports that had been provided to the FDA over a period of 1 year. Suffice to say that there are many reports of inaccurate results, false positive results, or false negative results. So this is not a one-off issue. Quick point, there are only 4 MDRs from curative. Only 4 out of these nearly thousands of reports. So I was confused. Why would FDA issue a safety communication when there are only 4 reports from curative and hundreds of reports from other manufacturers? There might be some issue going on, or FDA thinks that by highlighting this issue, which is commonly seen across the board, like self-collection, tens of thousands of sites, maybe they are giving a message to other test manufacturers to start monitoring their rates of false negatives and do something about that. As I said, it's pure speculation on my part. Then I got also curious. This is molecular diagnostics, but what about antigen test? Well, there's a code for that too. You can look up QKP. And here's the data for antigen test. Same situation. Thousands of incorrect, inadequate, imprecise results. Many false positives, many false negatives. So the conclusion is that this is actually a pretty common problem. And you would think that the test accuracy overall is pretty bad. But let's put things into perspective. And the reason I say this is we know hundreds of tests have been authorized by the FDA. Now, over 200 RT-PCR, 70 antibody tests, 14 antigen tests. And many of these tests are routinely used. So there is data from the CDC. Let's see if it's a big problem. There's a CDC tracker which tells us how many tests have already been done. Over 300 million tests have been done. So let's do a quick back of the envelope calculation to see if it's a big problem or not. Total MDRs, about 6,900. If I add up the QJR and QKP MDRs, total tests are about 315 million tests. So approximate rate comes out to 22 per million. 22 per million. Not Six Sigma, but definitely not too bad either, right? Hundreds of millions of tests have been done. Hundreds of tests are out there. And we are, in aggregate, we are coming out at about 22 per million of these MDRs, which pertains to inaccurate, false positive, false negative, other issues, major issues. Now, this is not a very precise calculation. So we are looking at only at a high level, back of the envelope calculation. But this gives you a sense of scale, whether it's a big problem or not. Now, I don't know if 22 million should be considered high. Certainly it is not Six Sigma as I mentioned, but it is a starting point. So let's put this into perspective. Let's say you are a manufacturer of one of these diagnostic devices. I think you should consider your post-market surveillance data. Look at the false negative rates, false positive rates, or any other issues. In my mind, 22 per million gives you sort of a baseline. If your number is significantly higher than this, you should take action. Again, your number should be the false positives, false negatives, or inaccurate results for your test divided by the number of your tests done in the market. So the ppm rate or parts per million rate should apply to you. And you should compare that to this number of 22. And let's say we are very imprecise in our number 22. Let's double it. Let's make it 44. Okay? Compare it to 44. Compare it to some baseline and start making decisions. Because I believe that by issuing this safety communication, FDA is clarifying their expectation and signaling to the public to be aware and take action. Because definitely this information is available to the FDA. Maybe they don't know precisely how many tests were done for your specific IVD, so they cannot do a ppm rate. But maybe they can estimate it somehow, right? They have access to medical records. So maybe they could estimate it. So maybe they're signaling to all of us in the industry to take note and take action. And this will be an indication of the effectiveness of your post-market surveillance system. This is the essence of risk management, closed loop system. Based on your estimated rate during design and development, you control all the risks. Then you launch the product. Now it is available in the marketplace and you're beginning to get data. You must take action, but many times people have this problem of what is my threshold? When should I take action? Well, this is one way of defining threshold. We have 1 year's worth of data across a variety of different testing scenarios, different types of tests. It should give you some sort of a baseline. Again, it's not precise, so let's not get bogged down by perfection. It gives us some indication. So it should be a way for you to evaluate where you are and whether you should take action or not. Okay, to summarize, FDA has issued a safety communication regarding one test, but I believe their view is much broader than that. And I wouldn't be surprised if they take targeted action behind the scenes, if they contact these IVD manufacturers specifically to report more data, perhaps, or take further action. We should not be surprised. So you need to take action within your organization and go back to your post-market surveillance groups and begin to ask these questions. How do we rank? How do we rate compared to a baseline rate? Or ask the question, what is a baseline rate? Maybe you don't agree with my 22 per million number, and that's perfectly fine. I'm just using that as an example for you. So that's the second point, is proactive action. Because you don't want to wait until the FDA issues a public safety communication against your specific device, because that'll be really a bad thing to happen in the marketplace for your brand. That's the purpose of your post-market safety surveillance process, not just a compliance activity. I hope this is useful to you. Let me know your questions, comments, and thoughts, particularly if you have new insights based on this. Any best practices you use in your post-market surveillance process that we could all benefit from. I invite you to share those thoughts. And finally, I want to thank you for your interest and attention, and I hope all of you are continuing to stay safe in these very difficult circumstances.